Hello class, this is the video for section 2.8, one-to-one functions and their inverses. Okay. The following are our learning objectives. One-to-one functions, we'll find the inverse of a function. We find the inverse, finding the inverse of a function. Okay, we will explain what the inverse of function is. We'll find it, we'll graph it, and then we'll apply it, okay, to a real life situation. So one-to-one functions and their inverses. Okay, the inverse of a function is a rule that acts on the output of the function and produces the input or the corresponding input. In other words, it undoes or reverses what the function has done already. Okay, now notice that not all functions have inverses. Those that do are one-to-one. All right, so if you have look at this graph, right? If you look at this is a function, but it's not one-to-one because -1 and then +1 all will give me the same value for y is equal to what? X squared, right? So this is a function, but it's not one-to-one. Okay. Now, let's take a typical example where we have a mapping with numbers and determine whether it's a function, it's one-to-one or not. So for example, the f, for every input, there is what? There is one. So every input has what? Only one image, a unique or distinct image. All right. This is a domain, that is your range. So this is a one-to-one. Unlike the g of x, it is a function, all right, but it's not one-to-one because the inputs 2 and 3 have the same output. And their output is the same, they are the same. This is not one-to-one. For it to be one-to-one, their images or their outputs must be distinct. They must be different from one another. Okay. So note that f never takes on the same value twice. So any two numbers in A, okay, have different images, whereas the G does not, okay, because 2 and 3 have the same image 4, as I explained. Now, if you put it symbolically, the G of 2 is equal to what? G of 3. That's what you are saying. But for it to be one-to-one, that must not be true. And of course, the x1 and x2, the 2 and 3 are different. And if they're different, they must have different images. That is why the G, function G, is not one-to-one. Okay, so here's a formal definition that a function with a domain A is one-to-one function if no two elements in the domain have the same image. No two. In other words, f of x1 is not equal to f of x2 whenever f of x1 is not equal to f of x2. In other words, if the inputs are different, we expect the output should also be different. They should have an image and they should be different. Now, equivalently, we can state this rule or this property or definition as what? If they are equal, that means that it's the same input that is producing the same output. Okay. Now, on a graph, we see that this graph here, this function, f of x, is a function, of course. It's a function, but it's not one-to-one because it does not pass what we call the horizontal line test. Okay, now for a function to be one-to-one, it must pass the horizontal line test. Okay, and then if we state that, we say that a one-to-one function, a function is one-to-one if and only if no horizontal line intersects its graph more than once. So looking at this graph, which is y is equal to x cubed, right? This is an increasing function, and it is a function because it passes the vertical line test. It also passes the horizontal line test. So it is a function which is one-to-one, and it's increasing. Now, every increasing function can also be it's also and not could, is also one-to-one. And every decreasing function is also one-to-one. Okay. Now, if you look at a line, just a typical line, this is an increasing function. It is one-to-one. It passes both the horizontal and the vertical line test. Every input has exactly what? One output, which is that, which is unique. Okay, it's increasing. And if you have another one that is decreasing like that, okay, that is also one-to-one. So every increasing function, every increasing and decreasing function, or decreasing function is what? One-to-one. Oh yeah. So if it is one-to-one, it has what we call the inverse. In other words, what reverses the what? The the what the function has done. Okay. So a one-to-one functions are important because they are precisely the functions that possess inverse functions according to the following definition. All right. If it is one-to-one, then it has an inverse and it's denoted by f, okay, f minus one. That is f inverse. That's why we said f inverse. Okay. We said this is what? F inverse. All right. Now, if it is so, if the f inverse on the output yields what? The input. And if that's the case, of course, f of x is equal to y. All right. Now we can demonstrate this that in the diagram that this is your domain, that is your range. Okay. So the domain of the inverse function is the range because it takes an input and then brings you what? The output of it takes the output and gives you the input. Whereas the function takes the input and gives you the output. And so the range of the inverse function is the what? The domain of what? Of the f. Okay, this is the domain of f, and then it is also the range of what? The inverse function. The range is a domain, the range of the f, but it's also the domain of what? The inverse function. Okay, so let's use numbers and see if we can understand this better. Okay, f of 1, the input is 1, the output is 5. 3, it is 7. 8 is negative 10. Okay, we want to find when we have the inverse of what? The output, which is 5. The output is 7, and the output is what? Negative 10. What are those values? Oh, well, since by the definition, the inverse function of what? At 5 yields the what? The input, which in this case is what? Is 1. So that is equal to 1 because we have this. Okay. And the inverse function at 7 is equal to 3 because f of 3 is equal to what? Okay, remember the definition is f inverse of y is equal to x because f of x is equal to y. That's exactly what we are doing. All right. And then lastly, for this part, this example, f inverse at negative 10 is equal to 8 because f of 8 is equal to negative 10. Okay. Now, if you put this in the diagram, the results, that's what we have. This is my f of x. That is my f inverse. F of x, and the input is 1, the output is 5, 3 it is 7, and 8 is negative 4, negative 10. Now, if the inverse function reverses the order, so it takes the 5 and gives you the input 1, 7, and gives you the output 7 and gives you the input 3 in that order. Okay. So now, but we must be careful we don't mistake the negative 1 in this expression for an exponent. Okay, in other words, f inverse of x does not mean the reciprocal. What we are saying is that this guy here is never equal to 1 over what? F of x. Don't think of it that way. Of course, if you have 2 raised to negative 1, it's the same as 1 over what? 1 over 2. But for a function, we cannot do that. Okay, the reciprocal function 1 over f of x is written as this. Okay, it is f of x, or if you use brackets, all raised to what? Negative 1. This will give me 1 over what? F of x, but not the inverse function. Okay. Now, if a function is 1-to-1 has an inverse, then we can use the composition of functions to determine whether really the two functions are what? Inverses. If they are inverses, then we have the we say that the f composed with what? The f of x, which is f inverse composed with f of x is equal to x, and the f composed with its inverse is also equals to what? The x, which gives you the input. Which gives us for the input. Okay, so that's for every x in A and for every x in what? In B. Okay. All right. Conversely, any function if inverse satisfy this equation is what? The inverse of the function. All right. So we want to take, how do we find the inverse function? Okay. These steps, I ordered it a little bit from the book. If you look at page 222, the first steps is the same. The second step in the book says that solve this equation for x in terms of y, if possible. And then the third is for interchange x and y. The resulting equation is y equal to the inverse function. Okay. Now, and then it says that note that steps 2 and 3 in the book can be reversed. In other words, we can interchange x and y and then solve for y in terms of what? In terms of x. So this is what I'm doing here. I'm doing the otherwise, or on the other hand, okay, I let y equal to the function, interchange the x and y, and then we solve for y instead of solving for x as stated in the book. Okay, on page 222. All right, so now let's take example. Let's look at a linear function f of x is equal to 3x minus 2. Okay, we'll do this and also verify using the property. Okay, using this property, this f inverse composed with what? F is equal to the f composed with what is inverse, and should be equal to what? Each of them should equal to x. Okay, so we want to verify that. Now, we first, step 1, we let y equal to the f of x. Okay, so we do that. Then we have y is equal to the 3x minus 2. 3x minus 2. Okay, now 3x minus 2. Then step 2 says that interchange x and y. So I have what? X is equal to 3y minus 2. Then I solve for y. Solve for y. So we add 2 to both sides. So let's write it here again. Get 3y minus 2. We add 2 to both sides. Okay, we get x plus 2 is equal to 3y. Then we divide both sides by 3. Okay, so we get y is equal to x plus 2 divided by 3. So the f inverse, the inverse function in terms of x is equal to x plus 2 divided by what? Divided by 3. Okay, all right. We can state in terms of y as well, and then we get what? We should get the function, the inverse function. Now let us verify this. Okay, let's verify. If we verify, we have to do, let's do each of them. First, f inverse composed with what? F of x. Okay, so the inverse function is x plus 2. So where we see fx, we plug in the whole f of x divided by 2. Now f of x is what? 3x minus 2, then plus the 2 divided by what? 3. So this whole thing is my f of x. Okay, and that gives us 3x, remove the parenthesis, we get minus 2 plus 2, which is 0. And then 3, we're going to have 3x in the numerator. And divide by 3, you get x. On the other hand, let's find f of what? F inverse of x. Okay, f composed with f inverse, which is 3 times the inverse function, then minus 2. Okay, we get 3 times f inverse is what? X plus 2 divided by 3 minus 2. The 3's will cancel out, and then you have what? X plus 2 minus 2. and that gives us what? X. So you see that in both cases, we got what? X. That means that, of course, the f and the f inverse, these two functions are inverses. Okay, now let's go to the next example. It said find the inverse of what f of x equal. This is a rational function. Okay, that's a rational function. So take note of that. That's a rational function. Now we let y equal to f of x, which is which give us, okay, y is equal to f of x, which is equal to that. That's the first step. Okay, so equal to that. Then we interchange this step one with interchange x and y. So that gives that x is equal to 2y plus 3 divided by y minus 1. Okay, so now we want to solve for y. Solve for y. Solve for y. That means we cross multiply this guy. You have x times y minus 1 equal to 2y plus 3. Okay, then you get xy minus x, that is this times that, okay, is equal to 2y plus 3. Now we bring all the terms involving the y to one side. And so we're going to add x to both sides. Okay, so that cancels out. And I have xy on the left-hand side equal to 2y plus 3 plus x. Okay, then that gives us, and to do it again, I need to subtract what? 2y from both sides. So giving me xy minus 2y equal to 3 plus x, which is the same as what? X plus what? S plus 3. So now I can factor y from both on the left-hand side and get what? X minus 2 equal to x plus what? 3. Then we divide both, since we are solving for y, we divide both sides by yx minus 2. X minus 2. Okay, so you have y is equal to x plus 3 divided by x minus 2. And this is equal to the inverse function in terms of x. Okay, now we can graph the inverse function. And to graph it, okay, let's start with this diagram here. If you have a point on the function AB, if you reflect it in the line y is equal to x, it becomes b and a. So in other words, you switch the x and y coordinates. So the graph of a function, the inverse function, is obtained by reflecting the graph of the function in the line y is equal to what? Is equal to x. Okay, so if you have a function, a point on the f, you interchange the x and y coordinates, and that becomes a coordinate at a point on the what? The inverse, and vice versa. Okay, reflected in the line y is equal to x. Okay, so here's the example. You have sketched the graph of f of s is equal to what? Is equal to square root of x minus 2. Okay, use the graph of f to sketch the graph of 4. All right, and then find an equation for the inverse function. All right, so first, if I want to graph this function here, I must know the basic function. The basic function in this case is what? Y is equal to square root of 4x. And then you know that the domain is greater than or equal to, x is greater than or equal to what? 0. All right, so if it's that graph, okay, this graph here, you have this function. Okay, this is your y is equal to the square root of x. And since it's minus 2, we move to the opposite side. That is, you shift it to the right, the horizontal shift to the right, 2 units. So you have this point 1, 2, then that becomes this graph. This point moves to what? 2 points, and that becomes that. So this is y is equal to the square root of x minus 2. Okay, now if I have this graph, the blue, or the purple, I want to reflect it in the line, y is equal to x, and then get that. So let's see how we do that in part B. All right, now I'll pick 2 points, 1 or 2 points. So we have this point, the coordinates of this point are 2, 0. And then if it's 3, the coordinates is what? It is 1. Okay, so this point has a coordinate 3, 1. Now, if I reflect any of these points in the line y is equal to x, it becomes, you interchange the x and y coordinates. So that's why this is what, 0, 2. And this point becomes, if it's come 1, 3. Okay, so this point here, okay, this becomes what? The coordinates 1, 3. And with that, we have the graph of the inverse function as shown. And then we want to find the x and the inverse function. Well, we let y is equal to that. Okay, y is equal. We want to note that the y is greater than or equal to 0. Okay, that's the domain. Okay, so that's step 1. Then step 2. Step 2, we interchange, we let y equal to that. So we have y is equal to, we interchange the x and y. So it becomes x is equal to the square root of what? Y minus 2. Again, don't forget that. Okay. And then when you square both sides, okay, square both sides, you have what? X squared is equal to y minus 2. Then we add 2 to both sides. That gives me x squared plus 2 is equal to y. And this is your function, the inverse function in terms of what? X. Now, don't forget that the domain, this is true if your x is what? Greater than or equal to what? That's what the y is defined. It's greater than or equal to 0. Because look at this graph as we show that this is, if you have just without this restriction, the domain, you have this graph. This is how it looks like. Okay, this is for x squared plus 2, but this is 1 and 2. But this does not pass the horizontal line. That's why it is a restricted what? Restricted domain. Okay, restricted domain. All right, and then finally we have an application that is the local pizza parlor. The daily special is $12 for a plain cheese pizza plus $2 for each additional topping. So you're going to buy the no additional toppings, you get $12. But if you want additional, they add $2. It's a find a function F that models the price of the pizza with n toppings. And then B, find the inverse of the function F. Again, what does the inverse function represent? And C, if the pizza costs $22, how many toppings does it have? Okay, so solution, note that the price P, we're going to know that by the P of the pizza is a function of the number of toppings. All right, so if you do this, this means that the price is a function of what? N, where N is the number of toppings. And that gives us what? 12 plus what? 2N. Okay. And that is your answer for that. Because it says that $12 plus $2 for additional toppings. All right. Now, to find the inverse, we first let P equal to that. Okay. Now, all that we need to do is that the inverse function is when it's a function of the price. Okay, we just have to solve for N in this case. So we let P equal to that. It's equal to 12 plus 12N. And then we solve for N. So for N, and that gives us P. We subtract 12 from both sides, that is minus 12, okay, divided by, sorry, you get P minus 12 is equal to 2N, and divide both sides by 2, okay, Then we have n is equal to p minus what? 12 over 2. Now notice that if we want the inverse function in terms of what? N, that's when we interchange the what? X. Remember, x and y. This is like y equal to, and the n is x. All right, then we interchange the x and y. But since we wanted the inverse function is as a function of the price, okay, we're going to solve for n in this case, and we don't have to interchange at all. Okay, so this is be the inverse function. This time is a function of what? The price p, and that is equal to what? N. So given the price, I can find the number of toppings that I need. So if somebody wants to purchase, the inverse function is give the number of toppings for a pizza with the price N. Now, part C says that if somebody bought a pizza of costing $22, how many toppings does he have? Okay, additional toppings. All right, so the N, no, we know that N is what? Is a function of the P, which is P minus 12 divided by what? Divided by 2. Now here they give us the price is what? $22. So we substitute the 22 for P, and that gives us 22 minus the 12 divided by 2. And you get 10 divided by 2, which is what? Which is 5. So it means that there are what? 5 toppings. And I hope this is helpful. And thank you very much. And I'll see you in class this week. Take care.